Welcome viewers. In this video we will see the error detecting and error correcting code, one type of the binary code. In binary code there are 6 types available: weighted binary code, non-weighted binary code, reflective code, sequential code, alphanumeric code, error detecting and error correcting code. Separate video available for all these codes. Subscribe the channel for more videos and notification. Link is given in the description box. The material also available in the drive. Link is given in the description box. In this video we'll see the error detecting and correcting code. In that again two types available: parity bit and Hamming code. Parity bit is used to detect the error. If any error is there, it will detect. Hamming code will detect as well as correct the error. Right. So in this video we'll see the parity bit. Separate video available for Hamming code. So the parity bit is used for the purpose of detecting the error during the transmission of binary information. So it will only detect the error. Hamming code will detect and correct the error. So parity bit and extra bit included with the binary message to make the number of ones is either odd or even. So the parity bit is nothing but a extra bit that is added with the message. That is binary information means message. The message what we are sending, whether it is any error is there, that is our main purpose. We need to identify the error, any error in the binary information or message. In that we are adding the parity bit, say extra bit, so that it will make the number of ones is either even or odd. We are going to add the number of ones so that it will be either even or odd. The message including the parity bit is transmitted and then checked at the receiving end for the error. So before sending that, the parity bit is added in the message, then it is transmitted. At the receiving end, it is verified for any error is available. An error is detected if the checked parities does not correspond with one transmitted. Right? So this, if any error is there, that will be detected at the receiving end. The circuit that generates the parity bit in the transmitter is called a parity generator, and the circuit that checks the parity in the receiving is called a parity checker. Right? So we have parity generator and as well as the parity checker. Parity generator will generate the parity bit and add it with the message. At the receiving end, the parity checker will check the message for any error is available. So we have even parity and odd parity. In the even parity, the added parity bit will make the total number of one as even amount. Right? The two type, even parity and odd parity. Even parity means we need to add the number of ones so that the number of ones should be even amount, even number. Similarly, in the odd parity, the number of one is added so that it will make it into number of one as odd amount. Right? The count will be odd. Right? So the odd parity, number of ones should be odd. In even parity, the number of ones should be in even amount. Now we'll see the message, how to add the parity bit. So this is the message with even and odd parity. How to add the parity bit in case of even parity and odd parity. First we'll see the 3-bit message, ABC, 3-bit message. So we know that it is 000, 001, 010, 011. Then 100, 1001, 110, 111. So it is given in a sequence 0001, 1011. Then this bit is 1, again 0001, 1011. Right? So first we'll see the odd parity. So the odd parity, the message with odd parity. So this is the message 000. The parity is 1. Then 001. See, this number of 1 is here 1, odd number. This is also odd parity. So the parity bit is 0. Here also only one is available. It's an odd number. So the odd parity, odd number means the parity bit is 0. Here 2 ones are available. So the even number. So the odd parity, even number of ones available means the parity bit will be 1. Similarly here 1. Only one is available. Odd number. Odd number, odd parity means the parity bit is 0. But here 2 ones are available. Even number. But odd parity. Odd parity, even number of 1 available means parity bit will be 1. Similarly here also 2 ones are available. right? Even number of ones available. Even number of ones in odd parity, the parity bit will be 1. Here 3 ones are available, odd number, right? So odd number of ones, odd parity means the parity bit will be 0, right? So if the even number of ones available means we need to add the parity bit, make it as 1. If odd number of ones available means the parity bit will be 0. So this is the message, this is the parity bit. So after this, if we see that by combining this message and parity bit, only odd number of ones will be available. See here only 1 is available. Here only 1 available. Here only 1 is available. Here 2 plus 1. 3 ones are available. Here only 1 is available. Here also 3 ones are available. Here 3 ones are available. Here also 3 ones are available. So the number of 1 is here odd. After adding the parity bit, message and parity bit combined together, the number of ones will be odd only in case of odd parity. Similarly in the even parity, see this 0 0 0 0, right? So we need to add 0 only, otherwise if you add 1 it become odd number. See here 0 0 1, only 1 is available, odd number. So odd number even parity means the parity bit will be 1. Similarly here only 1 is available, so odd number, but even parity means add the parity bit will be 1. Here 2 ones are available, even number, so the parity bit will be 0. Here only 1 is available, odd number, so we need the parity bit will be 1. Here 2 ones are available, even number, so the parity bit is 0. Here also 2 ones are available, even number, parity bit is 0. Here 3 ones are available, odd number, so the parity bit will be 1, right? So the number of 1 is odd number means the parity bit will be 1. The number of ones are even number means the parity bit will be 0. So after adding this message with parity bit, if you combine message with parity bit, now only even number of ones are available. Here 2 ones are available, here 2, here 2, here 2, here 2, here 2, here 4 ones are available. So combining message and parity bit, the number of 1 will be even, right? So this is the message available. In case of odd parity, if the odd number of 1 means the parity bit will be 0. Even number of 1 means we need to add the parity bit as 1. Similarly in even parity, even number of 1 means the parity bit will be 0. Odd number of 1 means the parity bit will be 1, right? So that we can transmit the data either odd parity or even parity. Now we'll see the example. So the example 1 is given as even parity scheme. This scheme is coming under even parity. Which of the following words contain error? Word means nothing but information, binary code, binary information. There are 3 codes are given, 1 0 1 0 1 0 1 0, right? So in this there are 4 ones are available. Number of ones available is 4. 4 means even number. What is given here? Even parity, even number of ones are available, so there is no error. So the next word 1 1 1 1 0 1 1 0. So here 1 2 3 4 5 6 ones are available. 6 means even number of ones available. So even number of ones, even parity means no error, right? In the third one 1 0 1 1 1 0 0 1. Here how many ones are available? 1 2 3 4 5. 5 ones are available. So odd number, 5 means odd number, but what we are using? Even parity. Even parity, odd number of ones are available means the word is having an error, because in even parity the number of ones should be even, but here we got odd number of ones, so that this word having error. So the parity bit is able to identify whether the information contain error or not. We cannot correct the error, but we can identify the error, right? So in these 3, this first and second not having any error because even number of ones available, but here odd number of ones available, so contain the error. Now we'll see the odd parity scheme. One more example, we'll see one more example. So here odd parity scheme is used. Previous one used with even parity scheme. Which of the following word had error? Right? See the first one, 1 0 1 1 0 1 1. How many ones are there? 1 2 3 4 5 6. There are 6 ones are available. Right? So even number, 6 is even number, but what we are using odd number, odd parity. Odd parity, even number of ones available means it is an error, having an error, right? Similarly, next one, 1 0 0 1 1 0 1 0. Here how many ones are available? 1 2 3 4. 4 ones are available. 4 means even number. So we are using odd parity but even number of ones available. So this word also having an error. Then the third one, 1 0 1 0 1 0. Here how many ones are available? 1 2 3 4 5. 5 ones are available. 5 means odd number, right? So the odd parity, here odd number of ones available, so there is no error, right? So the first two word having an error because even number of ones available, but here only odd number of ones available, so there is no error. So in this video we discuss about what is mean by parity bit, how to add the parity bit in case of even parity and odd parity, and also we discuss two examples, right? So the even parity means there should be even number of ones. Even number of ones means the parity bit will be 0. If odd number of one available means parity bit will be 1, right? This is opposite. Odd parity, odd number of 1 means no problem. Odd parity, even number of 1 means we need to add parity bit as 1. So subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. Link is given in the description box. Thank you for listening.